Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at the binomial expansion. So what we're going to do is we're basically going to put everything together in this lesson. But before we do that, let's just recap on what a binomial expansion actually is, what it means to expand something binomially. So binomial means two. We've got bi in the, let me do that in a different colour. We've got bi in the title and bi means two. So we have two terms and we are expanding a bracket to a power of whatever the power is. Okay, so you kind of have it in this form, a plus b, two terms, and then we've got a power n. So some examples here, we've got 1 plus x squared. Remember what that is? That is just 1 plus x times 1 plus x. We've got 2x plus 3 to the power 6. That is 2x plus 3 times it by itself 6 times, so 2x plus 3 times 2x plus 3, etc. Okay, so that's another binomial expansion because we've got two terms and we are expanding it. Then we've got something to the power of 20. Now I would not like to do that by hand. That is a half a plus 4 to the power 20, so that is a half a plus 4 times by itself 20 times. I would not want to expand that by hand. Okay, and I put etc there because there's loads of other examples of expanding brackets. So in this video we're going to have a look at what the binomial expansion is, and it's a formula, if you like. It's basically how you expand the terms. You can basically substitute into this formula, this expansion, to give you the expansion that you need. So, before we do that, I just want to have a look at how combinations, what we learned in the last lesson, can come in really handy for the binomial expansion. And spoiler alert, they're actually in the formula. So, let's have a look. Let's say we take the example and we're expanding a plus b to the power 5. The term, and the term that's one of the terms that is going to be in there, is a squared b cubed. Okay, but how many times does that occur? How many times when we expand a plus b to the power of 5, how many times does the term a squared plus b cubed, how many times does that occur? Well, if we think about it, what we're actually doing is we are doing a plus b to the power of 5, so that's a plus b multiplied by itself 5 times. How can we get the term a squared b cubed? Well, if we think about it, a times a, that's going to give me an a squared, and then a times b is going to give me an ab, and then b times b is going to give me, the b times the a is going to give me an ab, and that's going to give me a b squared. So it's not going to come from the first two brackets, but if we think about the first three brackets being multiplied together, we will end up with a b cubed. And then all we need to do is just multiply that with an a squared. So really, to get this b cubed, what we need to do is we need to choose b 3 times from the 5 brackets. Okay, and it says that in the book here. Choose b 3 times from the 5 brackets. The reason we choose b to multiply 3 times is because we need that b cubed. Okay, so actually, if we're thinking about combinations, the term a squared b cubed occurs 5 choose 3 times. Because we need a b cubed, so we need to choose b 3 times, we need to multiply b by itself 3 times from the 5 brackets to give us a b cubed, and then just multiply it with an a squared along the way, okay? So that's how many times it occurs, and because it occurs that many times, we're going to, when we've done the expansion, add it up that many times. We're going to have a squared b cubed 5 choose 3 times. Now 5 choose 3 is 10, so we're going to have the sum of a squared b cubed 10 times. So what that means is the coefficient, when simplified, will be 10. Hopefully that makes some sense. So just think about that. Coefficient here is a key word because when we do the expansion in a minute, you'll see why, or you'll see that it's used, the combination is used as the coefficient, okay? So hopefully that makes some sense. If it doesn't, don't worry, just think about the formula, which is this, okay? This is, when you first look at it, pretty confusing, but actually if we break it down into terms, it's not that hard. So the binomial expansion is used when we are expanding binomials like this. Two terms, a and b, to some certain power, and the two terms are being added inside the bracket, and we're raising it to the power n. The first thing we do is create the first term, and the first term is just the first term inside the bracket to the power that we are raising it to. Okay, so a plus b to the power n. The first term is just a to the power n. And if you actually go along all of these terms, you can see the final term is, and that should that be b to the r? No, it shouldn't. Apologies. That should be b to the n. I thought that didn't look right. Okay, if we go all the way along to the final term, we started off with a to the n and we finish with b to the n. And then there's these terms in between, so let's explain those terms now. The second term, we can see, has a coefficient of n choose 1. n choose 1 is our coefficient, and then if we look from the a in the first term to the a here, we are decreasing the power of a by 1. But you can see we have added an extra b on the end. We multiply by b. And that's really because here what we did actually have in blue, if you like, is a power of b to the naught. Anything to the power 0 is 1, so we didn't need to write the b, but that's what we have in the first term, and we are increasing the power of b by 1 each time we go along the terms. So I'm just actually going to get rid of that because we don't really need it, and that 1 is not really there either. But we started off with a to the n. On the next term, we decrease the power of a by 1, and we increase the power of b by 1 as well. Okay, so decrease the a, increase the b. And we just have a coefficient of n choose 1. If you look at the powers, and I'll do this in yellow, if you look at the powers of b, we've got an invisible power of 1 on the b. They actually match the number on the bottom of the combination. Okay, so n choose 1 matches with the power on the b, which is a 1. Okay, as we then go on to the third term, we increase what we are choosing. So we're doing n choose 1 here. The next one we're going to choose 2, n choose 2. We're going to decrease the power of a by 1 and increase the power of b by 2. So that's quite simple. Okay, we now have n choose 2, a to the n minus 2 because we've decreased it by 1, so it becomes a minus 2, and we've increased the b by 1 to give me a 2. Then we basically have lots of terms, and this is just showing the general kind of term, okay? This is the second term, so we use a 1. This is the third term, so we have a 2. This is then the r plus 1 term, so we have an r. It doesn't really matter, I'm just showing the general form of the terms here. You could really get rid of that if that confuses you. You can just think, you know, you increase the 1 each time, you decrease the powers of a, until you get right to the end when you've increased the powers of b enough so that the b matches with what you were, or the power of the b matches with what you were actually expanding. Okay, so at the bottom here we've just got the definition of the combination in terms of the C notation, and also of course the factorial definition. And this you might not have seen before, you might have done in a previous lesson, I'm not too sure, but this basically says n is an element of the natural numbers. And the natural numbers are all the positive integers. Okay, so our power on the bracket has to be a positive integer for this to sort of stay true. Okay? Alright, I am just going to actually copy that. We'll do a copy so that I can paste it in a minute into my examples. So we're going to have a look at 2 examples, and it's pretty straightforward once you know what the binomial expansion is. All you have to do is just substitute and adapt it to your question. So, example 1 says use the binomial expansion to find the expansion of this bracket. And we are told to use the binomial expansion here, but if we didn't, we know that we've got 2 terms and we've got a power of 5. 5 is a natural number because it's a positive integer. And so we can use the binomial expansion even if we weren't asked to. And to be honest, I would do that because by hand, I don't want to be doing 3 minus 2x multiplied by itself 5 times. So let's use the binomial expansion. I will paste it in here and I will change it to a red. Have a go and see what you can do. Use the definition of the combinations to work out your coefficients here. Okay, work out what those are. Think that your power of A decreases each time by 1 and your B increases each time by 1. You have to work out what your A and your B are before you can sort of put them into the expansion, but just have a go. Even if you think about it, just do that. Press pause and have a go, and then we'll work through the answer. Right, let's have a quick work through the answer then. So, I'm going to have A and B to just be the two terms inside the bracket as they are. So, what we have is this. I will say A will be equal to 3 and B will be equal to minus 2x. Now, you don't really have to write that down. I'm just writing that down so you understand, but you must take the negative with it. If it was a positive, then it's positive 2x, but it's a negative, so we need to include the negative, okay? And my n is, of course, going to be the power on the bracket, which is a 5. Now all we have to do is just do substitution and then really use our calculator to help us do the calculations. So what we've got is we've got 3 minus 2x to the power of 5. I'm going to take the expansion and substitute. The first term is a to the n. So that's going to be a, which is 3. It's going to be 3 to the power of 5. Okay, that's the first term done. We'll do the calculation in a minute. I'm then going to add n choose 1. N is, well, it stays the same for every term, and n is just the power on the bracket, and that stays constant at every term, so it's just going to be 5, and then choose 1, because that's the first time we use a combination. Then I'm going to have a, which is 3, but I'm going to decrease the power by 1, because I had a 5 on the previous term, so decrease it by 1 will give me a 4. And then b is minus 2x, and that's to a power of 1. Okay, let's continue. We're going to have 5 choose 2 next with a power of 3 on the 3 because our a is 3, and we're going to decrease the power each time. We had a power of 4 on the 3, so on the previous term, so now we're going to have 4 minus 1, which is 3, 1 less, okay? And then we're going to have minus 2 to the 2, okay? We're going to square that because we're going to increase the b each time. Then I'm going to have 5 choose 3. Hopefully you can see how the combinations are working. Like I said, we always have n on the top, which is the power on the bracket. This case it's 5, and we just increase what we're choosing each time. So 5 choose 3, 3 to the 2, minus 2 to the 3. Let's make that a little bit neater. Okay, and I'm going to come under here, plus 5 choose 4, 3 to the 1 minus 2x to the 4, and then I've got now to the end basically. I'm going to have 3 to the 0 in a minute, so I'm then going to have minus 2x to the 5, so that is where I finish, minus 2x to the 5. Now you could actually think of putting combinations on the end and the first term as well, okay? So I could have had a combination here, but the combination that I would have had would be 5 choose 0, which is 1. And then I would have had here 5 choose 5, which is 1. So you don't need to introduce those to the final term and the starting term. Just take those to be a to the n and then b to the n. Okay, so that is the expansion. Now all I need to do is I just need to do my simplification, and I'm just going to take this from the book. Now, because you've got an x here, you don't really need to include the x, because when you do that in your calculator, you're not going to get anything because it doesn't know what x is. So don't include the x, just include the 5 choose 1 times the 3 to the 4 times the minus 2. And that will give you the coefficient of the x. Then once you've finished with your calculator, you can just put the x back in. So, let me show you what I mean. I mean 3 to the 5 is 243. Okay, so that is my first term. And in fact what I will do is I will highlight that term came from there. The second term is going to come from the yellow, okay, and let's first of all do the coefficient. The coefficient will come from this, 5 choose 1 times 3 to the 4 times minus 2, and it's minus 2 to the 1, we just don't need that power of 1. Okay, when you put this into your calculator, this is what you get. You're going to get a negative, so let me change that to a negative. You're going to get negative 810. That's the coefficient, but then we had a x to the power of 1 being multiplied, so that is my x there. Okay. Right, let's do the third term, and let me just highlight that in yellow so you know where that's come from. The third term we will do in red, and that is the third term. So again, work out what the coefficient is. It's a positive this time, and it's positive 1080. And then we get an x, but it's not just an x, it's an x squared, because we can see here the x is with this power. The power is on everything inside the bracket here, so it's going to be x squared. And we kind of know that because we had x to the 0 in this term, x was not there, so it's x to the 0. We then increase the power of x to give me an x, increase it again to give me x squared. So your x increases each time. That is the term from the red, and then we had this term, which I'll do in green here. And when you do the calculation for that, it's going to be a negative 720, and then the x is going to be a power of 3, again because the 3 is everything inside the bracket, so minus 2x all to the power 3. Right, that comes from the green term. Then let's do the next term. I'll have to do a different colour. I will do it in blue. You can still see that. Okay, we've got a power of 4 here. So we're going to have x to the power of 4. And again, we can see we're increasing the power of x by 1 each time. The coefficient, when you put that into your calculator, is going to be, if I've done this right, let me think, 1, 2, 3, 4. Yes, I have. The next one is going to be a positive 240 x to the 4, and that is the purple one. Okay, and then the final term I will do in, I'm running out of colours here, I'll do it in an orange, is that minus 2x all to the power of 5, which is going to be a negative 32x and then x to the 5. That's our orange term there. So if I was just to box all of that off in red, that is our simplified expansion of that binomial bracket there. Okay, if we binomially expand that bracket, this is what we get after the simplification. Now hopefully you can see, if we do have a negative in the bracket, have a look at the signs. The first term is positive, the second one is negative, then it's positive, then the next term is negative, then it's positive, then the next term is negative. If we have a negative in the bracket, it alternates sign. Positive, negative, positive, negative, positive, negative. So just keep an eye out on that, okay? So that is your answer. We can see also as well, if you were to do this the other way, so if you were to expand 2x, minus, let me just put that back, minus 2x plus 3, if you were to expand it like that and use minus 2x as your a value and then or 3 as your b value, you would just get the exact same expansion, but this would be your first term, this would be your last term, and it would decrease in x power each time. So sometimes you are asked to give your answer in increasing powers of x. If that's the case, do it like this with your x term second. Or, if you want decreasing powers of x, then do your x term first. And then you will get it straight away in the order that you need. But don't worry about that, because it didn't ask for that. We just did the expansion straight away. So hopefully you were able to do that. Right, final example for this video. This one is a little bit easier because we're just being asked to work out the first 4 terms. And it's the first 4 terms in the binomial expansion of this bracket here. Now have a look, we've got a fraction coefficient on the x, we've got 10 minus a half x all to the power of 6. So we could again do this by hand, but you would be here a long time because it's a power of 6 and you're possibly going to make some mistakes. So what we want to do is we want to just do the binomial expansion. Use the formula. I think I can paste it in. Look at that, it's like magic. And I'll change it to red so it stands out. That's our formula. Think about what your A and B values are. What's your N? Remember, N is the power on the bracket. And then just substitute. But be careful that you get all the powers correct and that you get all the coefficients and the signs on the coefficients. Make sure you take that negative and the half with it, okay? So, pause and have a go, press play, and then we'll work through the answer. Right, let's do the expansion. I'm just going to do the expansion exactly how it is. So, let's expand that. And in fact, I'll write down that I'm having my A to be 10, B is minus a half x, and N is 6. Okay, let's do the expansion. 10 minus a half x to the power of 6. Following this red expansion here, which is the binomial expansion, we're going to have a to the power of 6, which is 10 to the power of 6, plus n, which is 6, and then choose 1. And then we're going to have a, which is 10 to the power 5, because we're going to decrease the power of my a, my 10, each time. Then we're going to have minus a half x to the power of 1, because we're going to increase that power each time. Then we're going to increase what we're choosing, so 6 choose 2, 10 to the 4, minus a half x to the 2. Then add on 6 choose 3, 10 to the 3, minus a half x cubed, or to the power 3. Then we will add on 6 choose 4, 10 to the 2, 10 squared, times minus a half x to the 4, because we are increasing that power each time, but decreasing the power of 10. Then we are going to have 6 choose 5, times 10 to the 1, times minus a half x to the 5. And then we have got to the point where the next combination is 6 choose 6. And we know that's just 1. We don't need that. So we're just going to have b to the n as our next term. Okay? We're just going to have minus a half x to the 6. If you wanted to, you could, like I said in the previous example, write this term as 6 choose 6, 10 to the, well, it was a power of 1 here, so decrease it to 0. And then minus a half x to the 6. But we know that this is 6 choose 6 is 1, times 10 to the power of 0 is 1, times that. So actually it's just that bit of the term. That's why I just write that down straight away. Okay, hopefully that makes some sense. So all we now have to do is basically do our calculations, and I would definitely use your calculator for that. Now let me write down the bracket again, so we know what we're expanding. And this is what you should get. And I'm going to read it straight from the book to save me time typing it into my calculator. And actually, they are very big numbers. Of course, we've got 10 to the 6, so we have got 10 with 6 noughts, so that's a million. Okay, we've got 1 million there minus, is it 1 million? Yes, it is. Minus 300,000 x, so 300,000 x, like that. That comes from this term there, okay? And it's a negative because we've just got a negative to the power of 1, so it stays as a negative. The next term, these are very big numbers, is a positive 37,500, and increase your x power by 1. And then we have got minus 2,500x cubed. And of course, that carries on. Now, I'm going to stop there because this was the full expansion. And really, I didn't need to do the full expansion because all it asked me to do was the first 4 terms. So in my calculation, I don't really want to waste time doing these three here. I'll put those in red. We don't really want those three red ones because they are not the first four terms. We only wanted the first four terms, so I could have stopped there if I really wanted to. I will do that in my calculation by putting dot, 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 okay? Those are the first four terms, but the expansion does carry on with these three. But we don't need to write them down because it just asks us for the first four terms. So that there is our final answer for the expansion.